How are we doing?
I mean, honestly, none as bad as I could have. Can we just take the quizzes I've been to?
What's going on? What do you want to do, Mackenzie?
Take the quiz first half. Just get it over.
Here's the deal. The school made a mistake. He doesn't have any quizzes ready right now, so we can't even do it today if we wanted to. So I'm just gonna be point blank and honest. It's like I just plumb forgot.
So how about this is a sign? It's the Christmas spirit.
Yeah, I mean, so shh. Okay. I know. Everybody, get it out. Let it out. Get over your excitement. Okay. Great. So yeah. Go ahead. No, go ahead. We can do that.
Number 17.
Sure, we can spend some time doing that. So this is 3.9, you said? And you said number 7? 17. Thank you. Okay. So a man starts walking due north at 4 feet per second from point P. 5 minutes later, a woman starts walking south at 5 feet per second from a point 500 feet due east of P. So here's P. And I'll call this point over here Q. Okay, at what rate are the people moving apart 15 minutes after the woman starts walking? Okay, so here's kind of my picture, right? And we're looking for that, how that distance is changing. Everybody agree? Yep. Okay. Does that feel okay with the drawing and match the words? All right, let's start constructing here what we know. So we're going to need to give, well, let's think about, I guess, for a moment, the what kind of an equation do you suppose we're going to be using in this? Yeah, that's what I would be thinking, because really what this is going to come down to is this is like the 500-foot side. That's constant, right? That part's not changing. I'll call this side Z, and we'll just call this side X for lack of a better word. Is everybody okay with that? Okay. So what are these quantities going to be called then? We have two rates. Well, there should be DTs because they're both per second.
Because they're both what?
Per second. If I look at the rates, I know that these are,
Time.
yes. Yep. These are DTs. Mackenzie?
Is this the triangle, like the larger one? Is it just like a large version of the two smaller ones? Oh, wait, it's not.
Yeah, so that's the hang up here, right? Is that you'd really probably want to think about it as one triangle. It's a question of how do you resolve this piece, which is going to be made up of both of those, right? Somehow those rates have to combine together to give us our dx dt. You guys agree with that? Now, Mackenzie poses a point here that we could probably think about this as two separate triangles and try to add them together. That's probably not an unreasonable idea. The question becomes, what do you do with that piece? Because it's not going to just be 250, 250, because they're going at different rates. We know that's not going to be, and the further they go, the more one-sided that segment becomes, right? That the right-hand triangle there that side becomes a little longer, the longer time goes, because the direction going from Q, or that rate at Q, is bigger than the rate at P. Does everybody kind of see that? So we could try to do that. I think that would be doable. I would probably think it's going to be easier to do it as one triangle like I've drawn there on the right, but it's not an outrageous idea to try to think about it as two separates. The question really just becomes is how do I take those 5 feet per second and 4 feet per second and turn those into some kind of dx dt. Right? If we can do that, then it should be okay. You guys agree with that? Okay. So how long, say after 1 second, how long is that side x going to be? 9. Right? Because what you're really doing is you're taking and just slapping that over there, right? Do you kind of see that? The way to visualize what's going on here?
Right, and then say, after 1 second,
Mm-hmm.
but then say she starts walking after 5 minutes.
Oh, sure. Okay. Interesting. I missed that piece. Ugh.
No, she doesn't start walking after 15 minutes. They're asking for the rate.
So 5 minutes, 5 minutes.
No, it says 5 minutes later, a woman starts walking. Okay. That's fine though, right? So here, let me redraw this. We're just going to redraw this real quick. So 4 feet per second for 5 minutes. How long has that been? Nope. 4 times 5 times 60, right? So that's 1,200 feet. And then we're still going at 4 feet per second. And this one is going at 5 feet per second. And then we're looking for this. Everybody's okay with that? Okay. So at time 0, you have 1,200, 500. The other side's going to be 1,300. Mr. Kulik recognizes that's a 5, 12, 13. That's a Pythagorean triple. You should not have any reason that you'd want to recognize that, but 15 years a math teacher, that's what you get. At time 1 second then, that side x is 1,209 feet then. Everybody agree?
Why 1,200?
Because they were 1,200 feet apart at time 0. 1 second later, one person's gone 4 this way and the other person's gone 5 that way. So it's gotten 9 feet longer. Everybody agree with that? So I would say that this is that dx dt should be 9 feet per second. Because at every second, that side is getting 9 longer. Everybody agree with that? Okay. Oops. So if we use our Pythagorean theorem, we get that. Now, why did the y squared become 0? Yeah, y was the 500 feet. That part's constant, right? The horizontal distance between the two people walking is constant. Everybody agree? Okay. So 15 minutes after the woman starts walking is at t equals 20, right? You guys agree with that? This was like t equals 5 down here. Well, 5 minute. Now I need that because I need to figure out the length for x and the length for z to plug in. Mackenzie?
You said it's 20 because of the 15
Right, yeah. So it's 5. The woman starts walking 5 minutes after the man started. So really the people, like somebody's been walking for 20 minutes at that point. Because it's 15 minutes after the woman started walking. So the man had a 5-minute head start. So it's like 20 minutes. So side x then is going to be the 1,200. That was the 5 minutes head start. And then we have 4 times 15 times 60, and then plus 5 times 15 times 60. So that's 9,300. And then z is just going to equal 9,300 squared plus 500 squared. I'm sorry, square root of. So dz dt, that's what we're looking for. It's going to be 2 times 9,300 times 9 divided by 2 times the square root of 9,300 squared plus 500 squared. I think. We'll check in a second to see if that pans out in the answer. the old answer book, or if somebody has the solutions pulled up, I could just ask, I suppose. Although if it's not the right number, I suppose I'm looking it up anyways, right? I don't know what I would have done wrong here, but it's possible I did something. So I get about 8.99. Feet per second. That's the right answer? Yes!
Except, why do you have 9 in the numerator? Like, where's the time sign?
That is the dx dt. Right? That we said was 9. Because that's how long that side x is growing each second. Mia?
So, like, in general, how do you know, like, when to make those rates negative?
Oh.
Or would it be, like, you know, with the example of the cars,
So here's what I would say. These rates, these people are getting further away. That's why I know their rate should be positive. If they were getting closer together, then the rate should be negative because the distance between them should be shrinking, right? So here I knew the distance was getting further because they're walking away from each other, so the rate's being positive is what I wanted. Great question, though. So again, it told me in the problem, but it didn't tell me like explicitly. I had to just kind of infer it from the situation, which I know is everybody's favorite. Is like, oh boy, I have to use common sense here, just kind of like think about what's going on, which is hard, right? Especially it takes practice. Mackenzie? 37? 27. Yeah, why is it being a doo-doo face here? This is what, watch this. This is what it's displaying on the page where 27 is for me. I'll try it again. I'm just gonna close it and reopen it. We'll try doing this way. 249 was the page. Yeah, let's try it again. All right. So it's you want to just read it for me? I know, I'm very disappointed. This guy. Okay. Gravel is being dumped from a conveyor belt at a rate of 30 cubic feet per minute, and its coarseness is such that it forms a pile in the shape of a cone whose base diameter and height are always equal. How fast is the height of the pile increasing when the pile is 10 feet high? And they were kind enough to give us a picture here. And we have like some chute up here that's dropping our gravel. So we're told that the gravel is being dumped onto the pile at a rate of 30 cubic feet per minute. That would be dV dt. And that's positive because it's being dumped on as opposed to like draining out or whatever. So I think that using the volume for a cube, or I'm sorry, for a cone, makes the most sense here because that's the shape of our pile. Now we're told that R is equal to H. So we'll just make that H cubed because it's asking us for dH dt when T is, when H is 10. So far, so good, Mackenzie? Okay. So differentiate dv dt is equal to 1/3 pi times 3h squared dh dt. So the 3's cancel there. So I'm going to have dv dt divided by pi over 10 squared. And that should do it. So we have dv dt was 30. We have pi times 10 squared. So about 0.095 feet per second. Is that the right answer? Oh, you have no idea. Let's look it up. Before, you were the one that was telling me that what the other one was. I just assumed you had this one. Nope. All right, let's look here. Oh, Mackenzie. I know it. This is dumb. I misread the problem. Because it doesn't say the radius and the height are equal. It says the diameter. So 2r is equal to h. So r is equal to h over 2. So this spot here will become h squared over 4 times h. So I'm missing a factor of 4 over here. Or an over 4. So that should have a 4 up there. And I think if I just take that and then multiply it by 4, I should have the right answer. Yup, 0.38 is about right. Yes. Yes. Is that okay? Sorry about that. At least it was kind of a simple mistake, right? Mia. 28. Sure. Again, I can't screen cap this because I think this is on the same page as 29 is, or 27 is, yep. So I'm just going to read it. A kite 100 feet above the ground moves horizontally at a speed of 8 feet per second. At what rate is the angle between the string and the horizontal decreasing when 200 feet of string have been let out? Okay. So here's our kite. Here's the ground. It says it's 100 feet above the ground. And it's moving horizontally, so I'm going to call this side X, this side Y, this side Z. So I know that dx dt is 8 feet per second. And it asks, what is the rate at which the angle between the string and the horizontal, so I'll call that theta. So d theta dt, when what is the rate between the string and the horizontal decreasing when 200 feet of string have been let out. So right away I know that this needs to be a negative value, right? Okay. So what relationship do I want that's going to relate theta and x? What are my options here? Because we know about dx dt, so we're going to need to use that. So tangent, or I could use cosine, right? Now, which one of those two would be the better choice? Tangent. Why? That's a constant, right? Everybody's cool? Okay. So I agree. I love that. It's like, yes, give me constants. So tangent is opposite over adjacent. Now let's differentiate with respect to t. So the derivative of tangent is secant squared, and then I get a d theta dt there. And this is 100 times x to the negative 2 times negative 1. Everybody's okay with that?
Oh, yes.
Okay.
You could have just made that one.
Yeah, you could have. I'm just trying to show the power rule going on. Everybody's okay? All right. So, do we have any of these values to plug into this currently other than, and then the dx dt, of course, Mr. Kulik. Other than dx dt, do we have anything else to plug in? No, but it's not hard to get the other things. So I know that z is 200 right now. So I can use the Pythagorean theorem to find x. Oops, that's not supposed to be plus though, right? That's a minus. So that's the what, square root of 300 then? No, not at all, Mr. Kulik. It's the square root of some big number. Let's not worry about it. Everybody's okay with that though? Okay. Secant squared theta. How am I going to do that? SOHCAHTOA, secant is hypotenuse over adjacent. Oops. So in our triangle, that's just z over x. So that's going to be 200 over that. All right. So d theta dt is going to equal 100 times the square root of 200 minus 100 squared to the negative 2. I'll just put the negative sign there. Times 8, that's my dx dt, divided by 200 divided by the square root of 200 squared minus 100 squared, all squared. So let's type that all in and see how we do. Actually, I'm going to do it this way. This will be the easiest. And I forgot the squared on that 200 there. I'll get it in a sec. So if I do the square root to the negative 2, that's the same thing as just to the negative 1, right? If I take a square root and I raise it to the negative 2, that's the same thing as the negative 1. I'm just making my life easier by having to type less junk into my calculator. Oops. And notice that I'm using that fraction command on my calculator so that I don't have to like monkey around with like 100 sets of parentheses. Negative 0.02. And what's the unit there? Radians per second. I guess we should double check that that is indeed the right answer, huh? I feel good about it. I love that it came out to be like a whole number or a rational number like that. That gives me a lot of confidence. Maybe you're not that excited. I was pretty excited when I saw that come out. Yep. The book said negative 1 over 50, but that's 0.02. So that wasn't so bad, right? Is this feeling any better? Okay, this is what I want to do the rest of the day. Sound good? You guys ready? I have some related rate questions on the my AP. So these are former free response questions. So you're not going to submit your answer through the my AP site because all it's going to do is have me grade that, like read them and grade them, and I don't want to do that off a piece of paper there. So I'm just going to use that as like, here's the questions I want you to answer. Just do them on a separate sheet. Work with somebody else, a partner, a group, whatever, I don't care. When you think you have a question correct, come up and talk to me and I'll check it and I'll let you know. So I called this I think, like, called it related rates. Okay? So I worked all these out in advance. They go from pretty straightforward to some of them are quite tricky. I think there's 6 of them in there. They don't have to be done today. But work with somebody else. Like, talk through stuff. At least one other person. Have a group. Talk it through. Makes this go much easier if you have somebody to talk to about it. It's a way to kind of reinforce your thinking or correct your thinking. Talking helps. Really, really does. And I don't care how many people you talk to. Right? As long as you're, like, contributing and getting something out of it, I'm happy. Does that sound okay, everybody? Yeah, we'll do this inside of the quiz. Deal. And here's the thing. You can show me as many as you want. Ask me if it's right or wrong. I'll just tell you right or wrong. I won't tell you what's wrong with it. But you can do that as many times as you want until you're convinced that you like where you're at. And we'll call it a day.
Still a section.
There's one more section after this one. It's not bad. It basically comes down to using tangent lines. Absolutely. Sure thing.